to figure out the expected value of something, what you're trying to do is figure out what's it worth. So let me just ask you a question first. Imagine this is a game where there's 4 envelopes and they're all dark red. So you can't tell, you can't see through them. You can't tell like whether they're empty or they've got a bill in it. You can't tell what kind of bill it is. There's just these 4 red envelopes up here. And if I said, I'm going to charge you $2 to play, you could either get nothing in the envelope that you draw, or you could draw one that has 50, or you could draw one that has 100, or you could draw one that has $2. Would you agree that if I only charged you $2 to play, that's a pretty good deal? And for some of you that are severely against risk, you might be like, well, there's a chance I'm going to lose money. Well, yeah, there's a chance of that. Because if you pick this envelope, you got nothing and you lost money. But then all the other envelopes, you either break even or you make money. And so, no brainer, $2, smart deal. Okay? Would you pay $50 to play this game? Man, it feels too expensive. Because then this one you break even, you lose. And this one you make money, but so how do you figure out what's, if you agree that $2 is a great deal, you'd probably play it. And $50 is probably too expensive. Somewhere between $2 and $50 is the exact fair amount to pay to play this game. That's called the expected value. You want to pay what it's worth, right? If you are going to buy something, you want to pay what it's worth. All right, so to figure out the expected value of this, you just got to take the probability. Oh, big surprise, we're in a chapter called probability. You got to take the probability of getting the $100 envelope and then times it by the amount you get if you get that envelope. All right, so probability of this envelope is, would you agree there's 1 in a 4 chance that you're going to get that envelope? Times, how much do you get? $100. Then just that part is worth $25. It would be worth paying $25 to play this game just to have a chance at that $100 bill. Okay, and then the probability of this one is 1 in 4, and the amount you get is $50, and that's a little harder because 50 divided into 4 parts isn't so easy, but I'll do the math for you. It comes out to, well, you'd multiply and it comes out to $12.50. So that part of it is worth $12.50. This part of it was worth $25. Do you see that so far it's worth like $37 to play? It's true. All right, so this one is how much, what's probability again? 1/4. What's the amount you get? $2. What's 1/4 of $2? Well, half of $2 would be $1. 50 cents. Very good. And last but not least, there's a 1 in 4 chance that you will get absolutely nothing. And of course, that's equal to 0. That's worth nothing. And then what you do is you probability times the amounts, and then you add them all up. 25, wait a minute, 37, raise your hand. 37, 50 plus 50 is $38. That is the exact fair amount to pay for playing this game. Now, in the real world, you're used to games like this being skewed so that whoever's created the game, like the lottery, they don't pay all the money back that people paid into the lottery, right? They make a lot of money on the lottery. They set it so that you get a bad deal. Same thing. Welcome, but you're quite late. 8:06. All right. So they set it so that, like, if you're in a casino, they don't make it fair. It's on purpose not fair. And you should have that down deep feeling like if I'm paying for something, I'm probably losing money on this deal. Because they almost always are. Because it's set that way on purpose. Casinos set it so that they're going to make money, on average. All right, so is $38 what the casino would charge to pay this game? No. But the casino, honestly, wouldn't charge like $50 or nobody would play. Because everybody'd see that it was a bad deal. But they might charge $40 to play the game. And see, on average, they'd only make $2 each time. They'd make $2. People would still pay it though, because they're like, even though they know it's a bad deal, they're excited. They have a chance at the $100. So if you pay $40, I've had a fair amount of kids would have done that deal and said, yeah, I'm going to pay $40. Heck, if I get this one, I make money. If I get this one, I make money. But on average, you'd still be losing. Because the fair value, the expected value was this. And they're probably going to charge you more than that. Okay, yes? You know the deal on this, right? Okay. All right, so next up, I'm going to give you one where it's completely different, but you're still going to do the probability times the amount and add them all up. Let's keep it at least this much the same. It's still envelopes. This time, got to show me the pass though. Oh yeah. It's this time you have a $50 envelope. It's a little lower stakes game. A $5 envelope. Here. Go ahead, you can go. A $0 envelope. And a $1 envelope. Would you pay $1 to play this game? Would that be a good deal? That's a good deal, for sure. Would you pay $30 to play this game? No, that's a bad deal. Somewhere between $1 and $30 is this expected value, the fair amount. So do the P times the A, probability times the amount for each thing, and then add them all up. Try it. You'll need a calculator to figure out your little 0.25 probabilities. So give this a try. You don't have to crack out the problem, but you need to try it. You need to type some stuff in the calculator. Probability for each thing is an amount that you get for each thing. And then you just add them all up. All right. Probability of this is 0.25 because there's 4 envelopes. You have a 1 in 4 chance of grabbing that envelope. And then you get $50 if you do it. So 0.25 times 50. This one, 0.25 times 5. Probability, amount. 0.25 chance of this one. 25% chance you're going to pick that envelope. And you get nothing. That's an easy one to multiply. And 0.25 times $1. I can do these in my head. Not easily. So half of 50 would be 12, or would be $25. So half of that is $12.50. So this part is worth 12.5. This part here is 1.25. This part here is 0.25, and this part here is 0. Add them all up. 12.50, 13. Wait. I'm going to add these two together first. Is $1.50 plus the $12.50 is $14. Raise your hand if you had 14. Awesome. That means that at $14, if you played this a whole bunch of times, you kept paying 14 and sometimes you'd win, sometimes you'd lose. But on average, you'd break even. If this was a charity, would the charity charge $14? No. They want to make money, which is normal. They'd probably charge, I don't know, at least $15. And then on average, they would make $1 every time somebody played. Okay. So that's how you got to factor that in at the end. If this is the expected value, and then there's this cost, if the cost is 15, then the new expected value is -1. You got to factor in what they charge. If it was free, it would have been worth $14. But it wasn't free. Got to subtract that 15. Our expected value is -1. Okay. I'll give you another example of how this happens literally to every single one of you at the beginning of the school year. Do you guys know that you can, if you want to, buy a warranty for cracking your iPad? You guys know that?
Yeah.
Yep. And you can pay, I don't know what it is. Does anybody know off the top of your head how much you can pay as the, like, then if you break it, we'll fix it? I don't know. I'm just gonna make up the number. I'm gonna say it's $50, but there's some amount. I could like email the principal and ask him. There's some amount where if you pay this, then we will fix your iPad for you and you don't have to worry about it. Now, a lot of people will just say, not gonna do that because, you know, it's probably not worth it. Why? Because people are thinking that's the expected value. I expect that I won't get value out of that. I expect to lose money on that, and that's pretty normal. Most times on these kind of plans, it is like a losing EV, expected value. So let's say how that would work. If your iPad works, you get nothing. If it breaks, I'd say it costs about, has anybody had a screen repaired lately on their phone or on an iPad? All right, then I'm just gonna make up a number. I think it might cost, yes?
I mean, the closest I had was like in 7th grade, but I think it was probably around like $100.
Yep, I feel like it's about $100. So we're gonna say it costs $100 to repair your iPad. So every single one of these always comes down to a probability, and I haven't said that yet. I wanna ask in this room, out of 30 of you, we'll have just a tiny little probability thing. How many of you during the course of high school so far have cracked a screen? 1, 2, 3, 4, 5 of you. Then 5 out of 30 would be our probability that you're gonna crack the screen, okay? So you do the probability times the amount. This is the amount, so the probability of that really doesn't matter because I'm gonna times it by 0. But the break probability was 5 kids out of 30. Probability times amount. Are you catching on? I've said it like 17 times. You take the probability times the amount, and then you just add them up. So the probability it's going to work is, well, 25 out of 30 of you, your iPad just worked. You didn't break it. Probability, amount. Probability, amount. Times them by 0 is super easy. 100 times 5/30ths. I have no idea. What is 500 divided by 30? 16.67. After you have the probabilities and the amounts, you add them up, and that's 1667. I rounded to the nearest penny. That's what it's worth. But you pay 50. You got to subtract that off. What is 16.67 minus 50? That's your expected value. If the school decided to give everybody that coverage for free, frankly, a lot of kids would abuse the heck out of it. They'd be like, oh, I got free replacement. Watch me. I'm going to just crack my iPad because I can, and they're just going to have to fix it. And so they probably won't ever give that for free because tons of people would just be stupid and break it just on purpose because they can. So this is your expected value. Now, I want to make sure you get, does that mean you're stupid to buy the coverage? No. No. Sometimes you know you have a higher probability than other people that it's going to break. Like, for instance, just where you store it is, like, say it's in your backpack, and you end up, like, you know you've cracked your iPad before and you're probably going to crack it again. Well, then your probability is different. So you might know that for me, this is a good deal. Or just for the peace of mind. There is some peace of mind. If you know your parents bought that, you're not as worried about it. If it does crack, it's not that big of a deal. They're not going to yell at you. They're going to be like, ooh, glad I bought the insurance. And everybody's going to be happy. So it might be worth spending that. So I'm just trying to say, it's not like people are idiots for buying the insurance. A lot of people buy insurance. Like once your house is paid off, did you know you don't have to have house insurance? If your house burns down, there's nobody going to give you any money. That would really suck. But you don't have to buy house insurance. But most people do because they don't have to worry about that. All right. So even though the insurance, you know you're losing some money because the insurance company's going to make some money. All right, so that is an expected value question. Here's one more. Let's say if the spinner lands in this area, you get $50. If the spinner lands in this area, you get $2. Now, did I make it clear enough? Probably not. I'm going to say that that's a 90-degree angle. $90 out of how many degrees is there total in a circle? 360. Then the probability of this is 90 out of 360. Could anybody just have known that that was 1/4 of the circle? Were you thinking that? That was smart, because that's right. 90 out of 360 is 1/4. So that's your probability. I'll just tell you the probability of this one. There's a 25% chance the spinner's going to land in there. And you should be able to use logic to figure out the probability of the other thing. All right. Let's say this game is free. Figure out for me what the expected value is. Okay, you take the probability if it happens times how much you get if it happens. 25% of 2 is 50 cents. This part, 75% chance you'll hit that on the spinner, and that's 0.75 times 50. That one's not a nice number, it's a decimal, so what is 0.75 times 50?
0.75 times 50 is 37.5.
Add them together, $38. That's the expected value. Do you think anybody'd let you play there for free? No. So then they charge $40 to play. You got to include that. Like some kids are just going to give this number and then they'll get it wrong. If they don't factor in the $40 and then say, oh, so then it's -2, you get it wrong. You're going to lose $2 on average to play that game. And that's really how casinos work and warranties work. Do you notice that even on Amazon now, if you buy something on Amazon, a lot of times it pops up with, do you want to buy the warranty? And it's only $5 to buy the warranty. And why is that? Because they make money on it. Even though it's only $5. If you do that times 1,000 people order your thing, you order your warranty, then you just got $5,000. And sure, you have to pay back a few of them, like, yeah, because the warranty, makes you have to replace their broken hose or whatever it was that you ordered, but they're still going to make money on average. That's why they do it. All right. So I'm going to give you one where it's just a little harder to figure out the probability. If you grab a red marble, you get a certain amount of money. If you grab a blue marble, you get a certain amount. And if you get a green marble, you'll get a different amount. Here's the key for it. For red, you get $10. For blue, you get $5. And for green, you get $1. Obviously, the least amount you can get is $1. So if they charged $2 to play, I'd say that's a pretty good deal. You're probably going to have an expected value that's positive because sometimes you're going to win $10. All right, so then I'm going to say cost $2. I would expect a positive expected value at the end. All right. Now you got your amounts here. Then all you got to do is get your probabilities for each one. And add them all up. Take a second. Figure this out. So I had a student ask a clarifying question. Yes, the number of marbles that are in here is actually what I meant. There were 3 dots. So yeah, there's 3 red marbles. 2 blue ones, 1 green one. And that'll help you figure out your probabilities like this. I don't want to make you wait too long to hear the answer. How many of you already have an answer? All right, that's not too many. All right, take a second. Get a decimal for each of these. Add them all up. So why is 6.83 kind of right, but not right?
I got 6.84.
That absolutely is correct. I just screwed up the rounding. Sorry about that. 6.84. Why is that correct, but still kind of not right?
We haven't subtracted the cost.
Yes, you have to subtract off the cost. The cost of the game matters, of course. Is it a good deal? Well, how much does it cost? It always comes down to the cost. Like if there was a car in the parking lot that was a piece of junk, but it ran, is it a good deal? Well, it depends. What does it cost? The guy's going to give it to you for free. What's a good deal? Car works. Did you know you can actually take an old car that is still running and you can get money just for the weight of the metal? Literally, you can just get, there's some value to the car just because it's got a lot of metal in it. So any car that still drives is definitely worth something. All right. I need to know how many of you got this or we're off by a penny from that. All right. And if you didn't get it, is there any part of this you didn't understand? Like maybe it was the probabilities. There was 6 marbles in here. And maybe you weren't doing your probabilities right. 3 out of 6, 2 out of 6, 2 blue ones, 1 out of 6. Add them all up. Maybe you forgot to factor in the cost. If you said 6.84, you were so close. All right. I want to give you one more that is an example from real life. There's this thing you can buy called a call option. Have you ever heard of options? It's in the stock market. Okay. And if there's an option on, have you heard of a company called NVIDIA? All right. So if you have the option on NVIDIA to buy NVIDIA at $100 a share, what that means is no matter later on, no matter what NVIDIA is selling for, you have the option to buy it at 100. Is it worth something? What if NVIDIA goes up to $200 a share? Then wouldn't you be happy to be able to buy it for only 100? Yeah, so it's worth something. Because now if a stock goes up like crazy, you'll make the difference. And so these options aren't free, they cost money. And then you can use expected value to figure out how much you expect to make on your option. But then here's the hardest part. You got to figure out what's the probability it's going to go up a lot. So NVIDIA makes these chips, and they're very popular right now. Tons of companies are buying these chips, really expensive, like computer chips. And if you think there's some reason that they're going to come out with some new really cool thing, like NVIDIA has said that they're going to make robots. And I think you guys know that I think robots are going to be a big deal in the future. Humanoid robots. They're going to be about your height, and they'll be willing to work all day for electricity. That's all you'd have to do is give them electricity, and they'll just work. And I don't necessarily think you're going to have them in your home for a while, because there's a lot of complicated things at home, like loading the laundry into the laundry and knowing what buttons to push and everything, that's pretty complicated. But there'll be bots that are going to be like, for instance, cleaning bots. I bet our school will have one pretty quick. And all of a sudden, they'll replace a custodian, somebody who's going to retire, and they're going to be like, you know what? Instead of hiring for that position, we're going to get a bot, because the bot will work literally 24 hours. They can even work when they're plugged in. So they could plug themselves in and then keep working. Just have a cord while they're charging. And the bot can be like cleaning the floors and stuff. So if NVIDIA is about to go up in value a lot because they launch these bots and all of a sudden NVIDIA is worth $900 a share a couple years from now, and you still have the option to buy it for $100, wouldn't you be happy you have that option to buy it for $100 when it's worth $900? Be like, yeah, that's a great deal. So if you thought that there's like an 80% chance, oh, I didn't put an 8 here, 80% chance that you think it's going to hit $900 a share. And sure, there's a 20% chance that it's going to be only worth, I don't know, still the same $100 a share. Then you can figure out what that's worth. Probability, amount. Probability, amount. And that'd be $740. And maybe that's what it costs. And then if it actually costs that much, you go, well, that's not a good deal then. I'm not making any money. My expected value is 0 if it costs that much. But I've found times where I've found options that seemed like, man, I think the probability is really high that it's going to go up, and so it's worth it. Expected value is positive.
How did you get 740?
720 plus 20?
Wait, sorry.
It's all right. And I'm not saying this is a completely accurate example, because you still have the option to buy it at 100. So really, it's more complicated than this. Now, this really isn't worth 900, it's worth 800, because you have to pay 100 for the things that are worth 900. And this really, if you buy it at 100 and it's worth 100, then you really didn't make any money. You didn't make anything here. So I just used round numbers and tried to give you an example that made it kind of easy to see that actually people in the real world do figure out expected values. They have to decide, is this worth it or not? And you always do the probability times the amount, and then you add them. If you can remember that, for every expected value, you got to figure out the probability for each thing and the amount for each thing, and then you just add them all up. And if there's a cost, you got to subtract that at the end. All right, it's a Schoology quiz. Find it. I'll do the first problem with you so you can get in the groove. You'll need your calculator for that. Olivia, would you read me number 1? You.
Me? 2,000 raffle tickets are sold at $2 each for a computer system valued at $1,500. What is the expected value if a person purchases one ticket, round to 2 decimal places?
And how many tickets did we buy? Just one ticket? Okay. All right. So I know that's a lot of words, and you're like, what does that even mean? Well, do you realize we have to find a probability? And then do you realize we'll have to figure out an amount? And at the end, you got to subtract off the cost to see what it was worth. See, they're charging $2 for these tickets. They're probably not worth $2. All right, so what's our probability of winning? Well, there's 2,000 tickets. So then there's a 1 in 2,000 chance you're going to win, right? What's the amount you get if you do win? The 1,500. Now, you don't even have to do this other one because, sure, there's a 1,999 out of 2,000 chance that you're going to get nothing. Why don't you have to even do that? Because timesing by 0, you're going to get 0. Okay? So, Probability times the amount. Probability times the amount. That one's 0. Add them all up. What number haven't I used yet? Yes. The cost. It costs $2. Don't forget to subtract the $2 at the end. All right. So let's actually do the 1/2000th. Get a decimal for that. Times that. I know it might look goofy because they might put it in scientific notation, but that's your decimal. It's your probability. Times the amount is 1,500. And you should have got 0.75 right here. You add them together is 0.75. Is it now worth 0.75? As in, is it worth 75 cents? Kind of, but what haven't I subtracted yet? The $2. You're going to lose money. Outrageous. Oh, that's what happens pretty much every time in real life. They price things so that you lose money and the company makes money. It's okay. It's a whole system based on that. Everybody kind of knows. If I'm buying a product, you buy a calculator. You know that did it. If it costs $100, you know it didn't cost them $100. It cost them less. They're going to make money. You know that. Okay. So there it is. There's your actual answer. And don't forget the negative because it matters. Positive ones mean you should do it, and it's a great deal. Negative ones means you're losing a little bit of money. All right. Let's go on. Question? Good question. I'm guessing that the Schoology quiz is not going to have the dollar signs. So let's do it no dollar signs. And if I'm wrong, I'll put that in as a correct answer. Number 2. Joe, would you read number 2? Is there 2 number 2s? Oh, no. 2 Joes. You, Joe. Yes.
Your company plans to invest in a particular project. There is a 35% chance that you will lose $30,000.
Minus
40% chance that you will break even, and a 25% chance that you will make $55,000. What is the expected value of this project?
I heard most of that. The one thing I didn't catch was, what's your chance of getting 55,000?
25%.
Okay. That sound like probabilities and amounts? Yeah, just multiply them out. Add them all up. Was there any cost to play?
It does not say any.
Okay, so then you don't have to subtract the cost. Now remember, negative numbers are different than positive numbers, so factor that in. This one will be a negative. When they said break even, that means you make $0. That's the easiest one to multiply. Anybody can multiply by 0. All right. Probabilities, amounts, add them all up. And if there's a cost, subtract that at the end. Yes, Mason.
So for the last question, it's talking about like the price and rewards in terms of cents. So should our expected value be in cents or in dollars?
I would enter your answer exactly like this, and if that's not a correct answer, I will put it in as a correct answer.
For like question number 4.
Oh, for question 4. Okay. Any answer in here, I would be shocked if we didn't put it in the total of in dollars. Unless it says specifically, answer must be in cents. Okay. So make it like, let's say the answer comes out like this. Don't say 135 cents. Say $1.35. Okay. All right. And you don't have to have a dollar sign. I will make sure that the Schoology quiz doesn't penalize for leaving off the dollar sign. All right. There was number 2. I'll leave the work up there so you can just finish that off. And that's all I got for you for today.